The question on your screen says three harmonic waves of same frequency V and intensity I naught having initial phase angle 0, pi by 4 minus pi by 4 radian respectively. When they are superimposed, the resultant intensity is close to, and then we are provided with a 4 different options. Now, in the question, according to the question, we know that there are three harmonic waves, and all the three waves have the same frequency, that is V, and also the same intensity, that is I naught. But the initial phase angle between them are different. So for the first wave we have 0, and for the second wave we have pi by 4, and for the third we have minus pi by 4 radian. So after that, in the question it is said that when they are superimposed, what will be the resultant intensity? So we have to find out the resultant intensity. Now we will look at the figure to have a clear understanding of this. So here is the figure. Now looking at the figure, you can understand clearly, and also you can understand the angle it is showing. For the first it is 0, for the second it is pi by 4, and for the third it is minus pi by 4. So we will add the amplitude by using vector addition. This we have done in class 11, so it's the basic. So the A resultant is equals to under root 2 plus 1 out of bracket A, and as we know, intensity is directly proportional to the square of amplitude. So we will try to put this into the above equation, and then we will get I resultant is equals to under root 2 plus 1 to the whole square I naught, which is equals to 5.8 I naught approx. So according to this solution, our correct answer is option A.